Hi students, today we will move on from triangles to look at some other shapes, some other polygons, and we will specifically focus on the measures of their interior angles. So a polygon is when we think of a shape, those are polygons. The definition is it's a closed figure. Enclosed means that if it was a fence and you put your dog in it, it wouldn't get out. And it's formed by, oh my goodness, segments, which are the sides of the polygon. That intersect at their endpoints and those intersection points are called the vertices, which is plural for vertex. Okay, so here are some examples and non-examples. The first two shapes, they are closed. Their segments or their sides intersect at the endpoints. So these are called polygons. The next two shapes are not polygons. So we'll talk about why. So include a few of these examples in your notes. This first shape is not a polygon because it has a curved side. So segments are always straight. So this one is not a polygon. Okay. The second shape is not a polygon because of this area. These segments don't intersect at their endpoints. They intersect somewhere inside the segments. Another shape that's not a polygon is a star that's drawn like this, because those sides also intersect not at their endpoints. Now a star drawn like this would be considered a polygon. So there's just some examples and non-examples. There are two types of polygons, convex and concave. For the rest of this class, we will only look at convex polygons. And this first polygon is an example of convex. The second example is an example of concave. And what makes it concave is that some of its interior angles are more than 180 degrees. So this angle right here is way more than 180. I also think of it as like, it kind of looks like that vertex was kind of pushed in. That's another way that I kind of recognize concave. But we're not going to be dealing with these shapes. We're only going to be dealing with convex shapes in this class. So polygons are given their names according to the number of their sides. And the letter that we use to represent sides is N. So we'll refer to that. We're going to learn a couple formulas in this set of notes, and we're going to use N in both of them. We're going to learn two formulas specifically. A three-sided polygon, of course, is what we've already been talking about. Those are triangles. You guys know that. And a lot of these you already know. So you might want to pause and see how many of these you can actually remember yourself. A four-sided polygon, there are lots of them. We've got squares, rectangles, rhombi, parallelograms, trapezoids, but altogether these are called quadrilateral. And a lot of these you can figure out by the prefix. The prefix quad means 4. The prefix tri means 3, right? A five-sided polygon is called a pentagon. Pent means 5. Okay. A six-sided polygon is called a hexagon. So after quadrilateral, they all end in agon. which is what polygon ends in. Hex means 6. If you go back to the this root of polygon, poly means many. And you might see that in other words that you learn, especially in some other classes like science. All right, let's go back to a 7-sided polygon we don't hear of as much. There are 2 accepted names. One is heptagon. Hept is a prefix, it means 7. Another one is septagon. And I'll tell you guys a story because sept sounds like September, right? So I'll tell you a story in a minute. An 8-sided polygon you've all seen is an octagon. That's what a stop sign looks like. Oct means 8. Octopus is another word, 8-legged. 9-sided polygon is called a nonagon. Non means 9. 10-sided polygon is called a decagon. Deca, decathlon, decade, those all mean 10. 11-sided polygon is 1 and 10 together. So 1 is un or un, and then decagon. So it literally means 1 plus 10. Un decagon. A 12-sided polygon, if we use that same pattern, is called a dodecagon. Do is the prefix that means 2. So 2 and 10 make 12. And then any other polygon after that, we're just going to say the number of sides, which is n, and then dash gon. So if I had a 30-sided shape, we would call it 30gon. Now, there may be some actual names for those shapes, but in this class, I expect you to know all of them up to 12. So here's a quick story. If you look at the prefix sept, oct, non, and deca, those also match up with the months September, October, November, December. Okay? And you're probably wondering, well, why isn't September the 7th month? Why is it the 9th month? Why is October the 10th month when oct means 8, and so on? They're all off by 2, and that's because our calendar, we used to have a different calendar. And September used to be the 7th month. October used to be the 8th month. And then it got moved. I can't remember all the reasons, but the calendar was changed, and that's why they represent a different number month. All right, there are 2 rules we're going to learn, 2 formulas. Here's the first one. It says the sum of the measures of the interior angles of a convex polygon with insides is. So the first formula helps you find the sum of the interior angles and it is equal to 180 times n minus 2. So if you replace n with the number of sides, subtract 2 times by 180, you will get the sum of all the inside angles. Now we know in a triangle that sum is already 180. So if you were to put a 3 there for the number of sides in a triangle, minus 2, that's 1. 1 times 180 is 180. But we've memorized that number. You can use this formula to find that sum for all shapes. Basically, as you're adding one side to a triangle, you're adding another 180 degrees. So a 4-sided shape would be 180 degrees more than a triangle. It would be 360. Add another 180 to go to a 5-sided shape, and so on. Here's an example. Find the sum of the interior angles of a decagon. So the first thing you need to know is what the n is, the number of sides. Deca means 10, so that means decagon has 10 sides. So our value of n is 10. So we'll just do 180 times 10 minus 2. 10 minus 2 is 8. So 180 times 8 equals 1,440 degrees. So the more sides, the more your sum of your interior angles is. Let's try another one. Find the sum of the interior angles of a 20gon. 20gon means that it has 20 sides. So we use the same formula. 180 times n minus 2, n is 20, so 20 minus 2 is 18. So 180 times 18 is 3,240 degrees. So as I keep adding sides, this number just keeps getting bigger and bigger. Now there is a more specific type of polygon called a regular polygon. And what that means, that's a polygon that is equiangular. A polygon that's equiangular. And if you remember, equiangular means that all its angles are equal. So, for example, and I'll just draw a picture real quick. Usually when we think of like an octagon, we think of it being very symmetrical, just like the stop sign, right? So in a stop sign, all of the angles are equal. This is an example of a regular polygon. These are the ones that you learned about when you were little, when you were first learning the shapes. But we could have an 8-sided figure that's convex that is not equiangular. It could look like this. Whoops. Right? So those angles aren't equal, and that's called an irregular polygon. So the formula we're going to learn about now does not apply to these type of shapes. It only applies to regular polygons when all the angles are equal. So if I wanted to find the measure of one of those angles, all I would do is take that sum that we just figured and divide it by how many angles we have, which is the same number as the number of sides we have. So the formula for each interior angle of a regular polygon, or one interior angle, is just the formula for all of them together, which is the 180 times n minus 2, and then divided by how many angles we have, which is also equal to n. So this is the second formula that I need you guys to know. So here are a couple examples. Example 3, find the measure of each of the interior angles of a regular dodecagon. Dodeca, do is 2, deca is 10, so this means n equals 12. Okay, so if I want to find just one of those angles, we're going to use that formula, 180 times n minus 2 over 2. Our n is 12. 12 minus 2 over 12. Now, I do want to point out a common mistake students put. Let's say they were doing this. Instead of 12 at the bottom, they'd put 10. So what some students do accidentally is they subtract this part as they're writing, and then they write 10 at the bottom rather than 12. Make sure you don't do that. So in both places where n is, those need to be the same number. All right, let's simplify. 12 minus 2 is 10, so in the top we have 180 times 10 divided by 12. And 180 times 10 divided by 12 is 150 degrees. Okay. All right, example 4. Same thing, find the measure of each of the interior angles of a regular convex 20gon. A 20gon is where n equals 20, the number of sides and the number of angles. So we're going to take our formula, 180 times n minus 2 over n. N is 20, so 20 minus 2 over 20 will simplify 180. 20 minus 2 is 18, so 180 times 18 divided by 20. And when you type that in your calculator, you get 162 degrees. Now, I want you to compare these two numbers real quick, the 150 from example 3 and the 162. The 20gon has more sides than the dodecagon, and each interior angle is a little bit more than each interior angle of a regular dodecagon. So as you increase the number of sides in a regular polygon, that interior angle is going to increase. Okay, in these next two examples, we're still talking about the interior angle, but this time it tells us what they should equal, 108 and 150. And it wants to know what are the number of sides. So you have to actually work backwards. So if one interior angle equals 108, I know that can be found by taking 180 times n minus 2 divided by n. The problem is we don't know what n is. So we've got to figure out how to solve this equation. The first thing we want to do is get rid of that n in the denominator, and we're going to do that by multiplying both sides by n so it'll cancel out. This is really important. A lot of times students forget to do this on the left side of their equation. 108 times n is 108n equals, and then on the right side I just have 180 times n minus 2. I am going to need to distribute that, so I can do that at this time as well. 180 times n is 180n. 180 times negative 2 is negative 360. The next thing we'll want to do is get all of our n's together. So I'm going to subtract 180n from both sides and get my n's on the left. I'm going to continue up here. 108n minus 180n is going to be negative 72n. Watch your signs. Equals on the right side, negative 360. And then the last thing we do is divide both sides by negative 72. So n equals negative 360 divided by negative 72 is positive 5. So n equals 5. And just one step further, the name of that shape would be called a pentagon, because pent means 5. Okay? Now, just a couple things about this problem. If you get to this point and that's not a whole number, then you did something wrong, because the number of sides will always be a whole number. So keep that in mind. Just to save time, I'd like you to pause this, and I want you to try example 6 on your own. I am going to tell you what the answer should be. It should equal 12 sides, which is called a dodecagon. So I want you to try this one on your own, and if you're not getting 12, I want you to let me know in class, and we will do this one together. So sometimes you'll see a problem like this where they have this shape, and they'll say find the missing angle. So let's look at example 7. First of all, we have to figure out what type of shape is this. So you count the number of sides, and I see that it has 6 sides, so n equals 6, right? It says find the missing angle, so it wants to know the measure of this angle right here. We do know the measures of the other angle, and we can figure out what they should all add up to. So remember, the sum is equal to 180 times n minus 2. Our n is 6. 6 minus 2 is 4. 180 times 4 is 720. So all 6 of those angles need to add up to 720. If we add up the ones that we currently have, those add up to 600 degrees. So to find the missing angle, we're going to take the sum of them all, which should be 720, subtract out the angles that we know, which are 600, and that'll leave us with 120 degrees for that missing angle measure. Now notice, this is not a regular polygon, so you could not use the formula for one interior angle. This would not work here because all of the angles have different measures. It's not equiangular. Example 8, find the measure of each angle. So this one's similar. So first of all, you have to figure out what type of shape it is. I'm counting 8 sides, so that means n equals 8. And to find the sum of all of those sides, it's 180 times n minus 2. N is 8, so 8 minus 2. 8 minus 2 is 6. 180 times 6 is 1,080 degrees. So that's what they should all add up to. Now this time I have expressions, so I want to set up an equation, and we did this with triangles. We added up all the measures and they equaled 180. We're going to do the same thing. We're going to add up all the measures and they're going to equal 1,080. So let's look at what I have. I have 6 angles that equal x. So I could call those 6x. I have 2 angles that equal x plus 20. So I could say plus 2 times x plus 20. You could also list out all the angles. You could say x plus 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 20 plus x plus 20. Or you could write it the way I did. And that should equal 1,080. Now we just need to solve this equation. So the first thing we're going to do is we're going to distribute that 2. So we have 6x plus 2 times x is 2x. 2 times 20 is 40. Equals 1,080. Now we can combine some like terms. 6x and 2x is 8x. And then that 40 we're going to need to move to the other side. So I'm going to do a couple steps in one just because I'm running out of room. The 6x plus the 2x is 8x. And that equals 1,080 minus 40 is 1,040. The last step would be to divide by 8. So x equals 1,040 divided by 8 is 130. So all of the angles that have x as their measure equal 130. So we'll say the x degree angles, well actually let's write it like this. 6 angles equal 130 degrees. Now the 2 angle measures that are x plus 20 are just going to be the 130 plus 20, which are 150 degrees. And we have 2 of those angles. So remember, there's 8 angles altogether. 6 of them equal 130 degrees. 2 of them equal 150 degrees. So prepare any questions you have for class, and I will see you soon.